I saw a blog post that said multi-tenant means consolidation of things like memory, processes, etc., but also the size of the database. How is that so? You still have the same user data and the same data dictionary. And that's a valid question, because one of the things we talk about when it comes to multi-tenant is if you have 20 databases currently that aren't multi-tenant, you have 20 sets of SGAs, 20 sets of background processes. And in case you haven't looked recently, there's like 60, 70, 80 background processes nowadays in a recent Oracle database. 80 processes on an OS is not a problem. 80 processes times 100 databases is a big drama. But a lot of those background processes don't do a lot. They sit there idle until they're requested to do work. But if you're an operating system and you have to regularly schedule time slice amongst 8,000 processes, even if they're doing nothing, that's an overhead and it costs you. That's one of the beauties of multi-tenant. But obviously, if I have 20 databases worth of data, putting them all into one multi-tenant database is still 20 versions of data. So how does the data get smaller? The key thing is the data dictionary actually gets smaller. And I thought we'd explain how that all works. Let's see if we can get this to see what happens here. So I'm going to run what did I call it? Metadata. I'm currently logged on just as my own user on this database in one of the pluggables. And this is an explanation of how we have kept the data dictionary down to a more manageable size, even if you have lots and lots of pluggable databases. I've picked any one of the dictionary views, DBA source, and the reason I picked that is obviously it's a fairly large table. It's DBA source as a view, but it sits on top of a dictionary table, which is all the PL SQL source for the entire database. It's a large object. If I copied this to every single pluggable I had, especially for all the DBMS packages that come with the database, that would be a big drama. Now, have we done that? Is that what happens? Is that why it takes a while sometimes when you create a pluggable from seed? Let's explore. So DBA source is there in my current pluggable. What if I try get the DDL for that DBA source view in my pluggable? I get an error. And this is the first inclination that maybe something special is going on behind the scenes. It says here that I do not have a view called DBA source in the sys schema in this pluggable database. Now, that's a bit weird because if I do a query from DBA objects in this same pluggable, it says you've got something owned by sys, it's called DBA source, and it's a view. So it looks like either a bug in DBS metadata or something else going on. We have to dig a little bit further into the dictionary to see how this is hanging together. If I look at the sharing column inside DBA objects, it says, yes, I have a thing called DBA source. Yes, it's a view, but there's this column called sharing. It says it's a metadata link. Now, what does that mean? A metadata link is our way of minimizing the overhead of an individual data dictionary for every single pluggable database. A metadata link says I'm actually a pointer to somewhere else. So let's explore where that pointer might be going. I'll connect now as sysdba as sys, but still inside the pluggable. I'm in pluggable number 1 here inside this database. I try the same thing, go get the definition for the view, and even in sys for this pluggable, I get an error. It's not in there. I need to actually go back all the way to the container root as sysdba. And now I can actually finally get some DDL of some sort. It actually says the view called DBA source is actually just a query from int $DBA source. So it's a view of something else. Now, maybe int DBA source is a table. It's actually a view. We can actually go get the dictionary definition for that as well. If I go look for the view of int $DBA source, it finally looks like the kind of thing you would see in all non-pluggable databases. DBA source in older versions used to look exactly like this. It's a join, we don't have to look at the specifics, but it's a join between sys.source$, where your code is, sys.user$, who owns it. It's basically the underlying core dictionary tables. The key thing here is it's only in the container. It's not in any of the pluggables as sys or even as my own user account. So metadata link is our way of saying, as long as you have something in your own pluggable database, which is simply a subset of what's in the container, we can simply point back to the container. All the system PL/SQL that comes with the database, DBMS output, DBMS random, DBMS, et cetera, et cetera, et cetera. They are just pointers back to what's in the container. That's the nice way when we plug in. If you create your own PL/SQL, that becomes effectively addenda in your own container. But all the stuff that is common between the root and the pluggables literally is only stored in the root, thus shrinking the size of the overall dictionary. You can actually replicate this yourself. Now, please don't do this. This is not actually supported syntax. I just want to show this is how we do it inside the database. You can actually see when it comes to doing, later on when you do application containers, there's this concept of sharing objects between pluggables. We use the same technology from the root down to the pluggables. It's effectively the internal version of application root sharing done as sys. So I can create, I'm logged on as sys, remember, I can create a view called my view. I'm saying it's going to be sharing as metadata, and it's just select username created from DBA users. You'll get an error on that because this is the kind of thing that's not meant to be done unless you're actually doing Oracle dictionary maintenance. So we stop you, and with good reason. The way we avoid it is this is what Oracle maintenance scripts do when you're actually applying patches and the like. We can set a hidden variable. As I stress, whenever you see a parameter with an underscore in it, you don't ever touch these without the guidance of Oracle support. We're assuming here we're doing some sort of internal dictionary maintenance as advised by Oracle support, and now I can create that view. I then log on to my pluggable, and you can see that view does not exist in the pluggable. Just because I create it in the root and say it's shared doesn't automatically push it to the pluggables. The pluggable actually has to create it as well. It creates it as its own copy. The syntax is identical. At which point you might be thinking, well, hold on. If I had to create it in the root and I had to create it with the same text in the pluggable, haven't I just got two copies? How do I validate that? Well, if I try get the DDL, if it was its own copy in its own database, its own pluggable, then this would work, and it doesn't. This is effectively a validation that that view does not really exist in this pluggable. And in fact, if I go query DBA objects, you can see it says, I am a shared object. The mechanism is a bit weird. We create it actually in the root and we create it in the pluggable. But when we create it in the pluggable, we look at the definition. If it's the same as the root, then we can actually have it as shared. You can actually query, it's a real view. I've just queried the first 10 rows. There's no smoke and mirrors. It's a real view. I query the view in the pluggable. It says, the definition is a metadata link. Go back to the definition in the root, get that, use that, and actually run it here in the pluggable. Well, what happens if I manipulate that definition in the pluggable only? I've said, yes, I want it to be shared, but I've given it a different definition. Is that going to corrupt my database? No, it's not. If I do that, the comparison fails. When I go look at my view, it actually is a genuine view now, and it's no longer shared with the root. If I recreate it back to exactly matching the root, then it will actually be back to matching the root container, and it becomes a metadata link, etc. So it's all managed for you quite easily. If you divert from the root, it's its own copy. If you don't divert, it's just a pointer back to the root. If I go back to the root now and drop it, what's going to happen? Because does it drop it in all the other pluggables? Because that is the only place where this thing is defined. It doesn't drop it in all the pluggables, but what it does do is break it. So if I now go into my pluggable, it says I can no longer use my view. It says it's invalid or compiled with errors in the root. So I can drop it in the root and drop it in the pluggable, and then it's gone forever. That's how we do it. But as I said, this is just showing you how the mechanism works. Please don't race off setting an Oracle script equals true and manipulating things in that data dictionary, because you're going to end up with a corrupt database for sure. That's hopefully a proof to you of how we can keep the data dictionary down to a minimal size. It's only going to be typically one copy of the sys schema with pointers out or metadata links out to all the pluggables, and then your own data dictionary objects will obviously sit in their own pluggable. But one of the good things is you're not going to have a 800 megabyte copy of the sys schema in every single pluggable. And hence we actually do consolidate the space in a multi-tenant database, which is pretty cool.